Hello, Geometry Honors. So you are in for a treat. Today, let me check that. Okay, I think we're good. Today we're going to look at writing and graphing equations of circles. So we don't always get to this stuff in freshman year for high school students. But yeah, we're going to write and graph equations of circles. And the equation of a circle is pretty easy to understand. It's if you got the center of a circle and its coordinates are h and k, and you got its radius as r, this is the formula. And what's interesting about it, it's derived from Pythagorean theorem. You can kind of see that. You got this quantity squared plus this quantity squared equals this quantity squared. And basically it's because if you've got a circle, you've got, oh, and actually there's a homework problem that kind of alluded to this, where it had different coordinates on a circle. And it turns out to find the measure of certain angles, you could realize, oh, I've got a right triangle in here. Well, yeah, this right triangle is going to change. The measures of it are going to change as you go around the circle, but the hypotenuse is always going to be the same, and it's going to be the radius. So anyway, that's where this formula comes from. The center is h and k. Notice they're minus there, and radius squared. So to write an equation of a circle and you've got its graph, that's not such a big deal. In this case, the center is what we're going to need. The center is at 0, 0. And we've got a radius here of 4. So we can go x minus the x value, which is 0, squared, plus y minus the y value, which is 0 squared, and that's equal to the radius squared. And that simplifies to x squared plus y squared equals 16. That's all there is to it. Yeah, that's it. That's the equation of that circle right there. And then it says on example 2, write the standard equation of a circle. And by the way, that's this format right here. Write the standard equation of a circle with the center at -2, 3, and radius of 6. So we have everything we need. We've got our h, our k, we've got our radius, and we're just plugging it in. So it's going to be x minus a -2, but if you minus a negative, you'll get plus 2. Squared plus y minus 3 squared equals 6 squared. And I guess we'll clean that up a little bit and just make it 36. So yep, that's the standard equation. If we were to write this in standard form, that might be a little bit different, but the standard equation of a circle is one in which you can easily see what the radius and what the coordinates of the center point of the circle is without too much issue. So example 3, we've got a point is on a circle, and then we've got the center of the circle. So you can kind of imagine what's going on there. The center's at 4, 2, but then we've got some other point here at 8, -1, so it might be out here at 8, -1. And this is the center. This is on the circle, so you can kind of imagine what that looks like. But they want us to write an equation of that circle. Well, we've got the center, so we've got h and k, but what we don't have is the radius. So we need to have a distance from the center to the edge of the circle, which we can find by doing the distance formula. So the distance, or in this case, the radius of the circle, is going to be equal to the square root of, and then the difference of the x's, so I'll do 8 minus 4 squared, plus the difference of the y's It doesn't matter the order you do them, but I know a lot of you would not like it if I did 8 minus 4 and then 2 minus -1. And I agree with you on that. But in this case, it really doesn't matter because it's going to get squared. So any sign differences are going to be eliminated. But yeah, we can do -1 minus 2 squared. And when you clean that all up, you get a radius of 5. And it's funny because the equation of a circle comes from Pythagorean theorem. So does the distance formula. It comes from Pythagorean theorem. You can, I think, see that. So anyway, now that we've got our center and we've got our radius, we can write our equation. X minus 4 squared plus y minus 2 squared is equal to 5 squared, which would be a 25. So equations of a circle, not too bad. We did have to do a little bit of work there to find the radius. All right, now we're going to go backwards. We're going to be given an equation of a circle and we're going to be asked to graph it. So if that's the equation of the circle, then our center is going to be at -1, +3, and our radius is going to be the square root of that. So our radius is 2. Square root of 4 is 2. And we'll plot this picture. -1, 3. And then we're going to go 2 all the way around. So that's easy to go to the right, to go up, to go left, to go down. And then if you notice, this is not a very good grid. I would probably change this in hindsight now that I'm looking at this. But I'd probably change it because these are not squares, are they? They're not. They're little rectangles. So our circle is going to look more like an oval. But it really shouldn't. It should look like a circle. All right, let's flip it over, see what else we got. So we've got a word problem of sorts. 3 forest ranger stations are at A, B, C. A fire is 2 miles from A, 3 miles from B, and 3.5 miles from C. Find the location of the fire by graphing. All right. So the key to this is they're not telling us in what direction on any of these. So we need to think about 2 miles away in any direction, 3 miles away in any direction, and 3.5 miles in any direction from those points. So we're going to be thinking about 3 different circles, basically. And once we graph these circles, I assume they're going to overlap because they say that the fire, we're going to find out the exact point that is these specific distances from these points. So let's solve it by graphing. Let's get a center of a circle here at -3, 2. And we know that the fire is 2 miles away from that. So we'll draw the, not quite a circle there. B's at 2, 2, and the fire is 3 miles away from there. Okay, so I'm going to go ahead and graph the whole circle, but I already know that it's got to intersect with the other circle to be one of the possibilities of the fire location. So at this point, I'm thinking it's got to be right here. And then we'll do the third fire just to verify. -1, -1.5 is the center, and it's 3.5 miles. And sure enough, if I go a half and then 3, I'm up here. So I'll just kind of cheat a little bit and draw that out. But where those circles intersect is at -1, 2. And that's the location of the fire. Okay, on the next one, a circle has an equation of x squared plus y squared equals 4. Determine whether the line y equals -x plus 2 is a secant, tangent, or neither. We're just going to graph it to find out. The center of the circle is at the origin. The radius is 2. And I will change this graph paper at some point. At least I think I will. We'll see. And then we'll graph that equation of that line. So the y-intercept's 2, and it goes down 1, over 1, down 1, over 1, down 1, over 1. We can also go up 1, back 1, up 1, back 1. And draw a straight line. Whoops. And there we go, pretty close. So class, is this a secant, a tangent, or neither? Because it passes through the circle, not on a single point on the edge, it's a secant. So to practice this a little bit, you might want to go to page 702, numbers 1 through 45, odd. And I'll provide some graph paper for you in class. Thanks for watching.